Hello, thank you for joining me today. Appreciate that. And today we're going to have lecture 6 about Suncor Firebag SAGD recovery scheme and NCG co-injection. And for those that listen outside of the course for Bachelor of Applied Technology Petroleum Engineering Capstone course, this is not a financial advice or anything. I'm not a financial advisor. This is a technical session from a public domain about the Suncor Firebag asset with emphasis on technology development and understanding of NCG co-injection in that asset. And so all my other videos are kind of related to this topic. So this is for information purposes only, and maybe for some entertainment if you're into that kind of stuff. So the focus today is going to be more kind of SAGD, NCG, understanding of the asset. This is a very important asset, currently the biggest producing asset, thermal asset in Alberta, probably in the world when it comes to thermal in situ recovery. And it just celebrated its 1 billion barrels a day aggregate cumulative production. And I think it's really important to see what was done, how long they've been operating for, what kind of production rates they're getting, and how they utilize technology. And again, information purposes only. And hopefully you enjoy this session. For the students, we didn't meet this week. It was a reading week, but we're going to be meeting in person next week. I'm going to be doing a little bit more hands-on work, trying to build some simulation files, doing some research in the lab. But this is kind of in support of your overall understanding of our course and the individual assets that you guys focusing on. And I'm not sure if anybody picked that specific asset, but I think it kind of provides a good overview of what was done when it comes to SAGD implementation and NCG integration. So as you can see here, we're talking Firebag project right now. The Firebag project commercial SAGD scheme is located right here next to Fort Mackay, kind of at the Athabasca River, and obviously Fort McMurray. And we have a big region here of mining assets. And so Fort McMurray is right here, obviously, and we have a big region of mining assets. And Firebag just happened to be close to those assets. Now, most of the SAGD assets are actually a little bit to the south. Of Fort McMurray. Firebag is one of those unique assets. They're still big, really good SOR, and it's kind of located very close to the kind of the shallower producing assets, which are mainly mining, right? And by the way, quick reminder that 20% of recoverable resource from oil sands is in the mining section, and 80% that is too deep to mine is of the resource is located basically utilizing SAGD and located underground, right? So it can be easily mined. So as you can see, basically in this picture here, maybe it's not as easy to see it, but the asset is kind of located more on that side of our province. And SOR on the asset is 2.72, as you can see here. Average bitumen production is 34,455 as of last year. This number is much higher right now, and I will provide an update on that as well. So this is not 217,000 barrels a day. This is more like 255,000 in January 2025, which is when I'm making this video. So you can see asset grew tremendously, and mainly because they had a lot of change in management and kind of operational strategy, a lot of focus on operational execution, and they've been growing this asset tremendously. So here's a picture of Firebag SAGD asset. So let's talk a little bit more specific about the production on the asset and kind of make our way towards NCG co-injection and what was done. Like we've done in other assets before, in green, we always have oil production. So as you can see here, oil production rate is in green. Steam injection rate, as mentioned, is always in red. So here's the steam injection rate. And water production rate is always in blue. And it correlates, as we discussed before, with the steam injection rate, because once you transfer the heat, the steam basically becomes water. So it turns into a liquid phase. And then that ratio between the steam to oil ratio should be very close to 1, which is what you see basically in this kind of relationship here. Then we have, like I said, we have the oil rate, water rate, steam rate, produced gas. So produced gas is in black. So let's take a look at the produced gas. So it's right here. The produced gas is right here. So you can see the unit for that is E3M3, right? So 1,000 cubes per day, standard cubes per day, or decks. So for example, on this asset, as of December 2023, the asset was producing 150 decks, or 150,000 cubes a day of steam production. And what we see here also as well, they actually specify for us in this case. Many other assets did not do that, but they say NCG co-injection, and you can see that NCG co-injection is this line right here, the kind of the gray line, and there was a huge uplift, and now it's kind of basically back to its normalized rate, which is very close to the gas production rate of this 150 decks a day, which is kind of cool to see that they keep in this material balance basically closer to 1, just like we have in this case. Steam to water ratio is closer to 1 as well. And the other thing they shared with us is the well count. So it's right here. It's about 330 or so, 330 producers. So it kind of gives you an understanding of overall assets and overall asset in Firebag and what was done. So we're going to spend a little bit more time on that because I think it's important. It's one of those graphs that historically we're spending a little bit more time on. Maybe I'll just use the purple color for everything, just kind of to limit confusion. So what was done here, let's talk a little bit more about the asset and what was done historically. So Suncor actually communicated this week that they're celebrating 1 billion barrels of oil produced on this asset in Firebag, 1 billion barrels. And so if we look at the time frame, this asset, the circulation for this asset started, I would say, mid 2023, which is right here. And then you can see ramp up in oil production that took place over the next couple of years. Initially, they actually didn't have much success. If you see, the steam to oil ratio was not very good, but over time they became really, really good in executing. And you can see right now the steam to oil ratio is 2.7, and they were able to get to kind of narrow the delta between the steam to oil, so the steam kind of efficiency, and basically not only grow production but become more one of the better producing assets when it comes to kind of environmental and operational execution, with low SOR of 2.7 or so. Okay, so now let's try to calculate if this number makes sense, 1 billion barrels. So if you take 1 billion barrels, and right now we're in 2025, so let's say oil production started kind of closer to 2005, even though it's not. It started a little bit earlier, but let's say 20 years to make it more simple. So then we'll take 1 billion barrels in our calculator, 1 billion barrels. So that's what I'm doing right now, dividing by 20 years and dividing by 365 days. So I'm getting average production for the asset per day, about 137,000 barrels a day, 137,000 per day. Now, on this scale, we're using cubes per day. So now we need to divide by 6.29. So I'm dividing this number by 6.29, and I'm getting 21,000.78 thousand barrels per day, 21,078. Okay. And if I'm looking here, where's 21,000? This is this line right here. So this is very logical right now, as we can see that we're somewhere in the middle between the first 10 years of asset execution here and the following 10 years. And so obviously because the production now is 255,000 barrels per day, right? So not 137,000. The next billion barrels a day, the next aggregated billion barrels they're going to be producing is going to happen twice faster, right? It's not going to take 20 years. It's going to take under 10 years to execute, because now the oil production rate is way more efficient. Now, what's really interesting that's been happening at Suncor, as you can see, is for Firebag, is that we have a lot of events that have been taking place, right? And this is expected from from every SAGD asset, and like in every SAGD asset, we have certain events we have to take into account. So let's talk about stage 1. So they have stage 1 and stage 2. You can see kind of consistent ramp up in steam capabilities, getting to 20,000 cubes and kind of plateauing here for a little bit. And then again, another growth. And then the major growth that was taking place came from being able to grow from stage 3 towards that stage 4, which is basically this line. And we've seen a lot of investment during that time frame towards those thermal assets, for many other assets as well, right? We've seen in many other companies, for example, we did Mega Energy, we talked about Synovus in the past, how there was really big growth during that time period, and a lot of capital investment that's been taking place. Essentially, I would even argue during that time frame, there wasn't a concept of free cash flow. A lot of the money was kind of ending up in this as part of this reinvestment ratio, when every time you make money, let's say on incremental oil production, you take that money and you just produce, basically drill more pads and spend more money on your capex to advance basically the facilities, the able to generate steam. And that's why this period was very important in company's history. And as you can see here, during kind of the downturn, nothing much changed. The steam kind of rate plateaued, which makes sense because they operated at their capabilities of the steam injection rate and produced oil basically with very limited decline for a very long time, around that 30,000 cubes per day. But recently we've seen a little bit of kind of ramping up of steam injection rate and increase in oil production rate. And that probably has something to do with optimizations, NCG utilization, being able to do more with less. And if they didn't spend money on new steam generation capabilities, that really allowed them the opportunity to grow and advance. And I think this is the real power around technology and innovation, because when, as you can see, when you do NCG co-injection, as you can see here in this line, it allows more opportunity to do more with that steam that we've had utilized before. And now incrementally, you can kind of grow production as well as you bring the NCG co-injection towards kind of late life strategy and execution for late life. And we talked in the past a lot about the NCG technology and what it does. Essentially, by definition, NCG co-injection, non-condensable gas co-injection, is injecting a non-condensable gas like a methane in situ that creates pressure in the reservoir and requires less steam integration. By definition, you get less heat transfer into the bitumen. But because you already developed a lot of those steam chambers, and those steam chambers merged in or coalesced in a sense, you don't have much incentive to continue injecting steam and increasing your SOR. As I mentioned, SOR on this asset, as they communicated here to us, is about 2.72. Now, before we go into more details about the nuances of what we see in the graph and the various events, like the wildfires, the maintenance, the turnaround, let me provide an update on what's going on right now with this asset, because as you can see here, the date is December 23. Usually companies report annually their presentations, the D54 presentations. And so we will have one next year that covers this year, basically the previous year. But I want to give you an update on what's going on right now with this asset. So as mentioned, they grew production significantly to about 255,000 barrels a day. 255. So the green line now is 255,000. And on this scale right here, you don't see it in barrels per day. So if we convert 255 to barrels per day, to cubes per day, we're at about 40,000 cubes. So we're at this level right here, which makes sense. So right here. So you see, like when you say it, it sounds like a big change, but on that scale, because the way we have steam here at this ratio of 2.7, I guess, and the secondary axis of y-axis, it doesn't look as big of a change, but it is. It's kind of a growth of at least I would say 30 to 40,000 barrels a day from 16, 18 months ago, which is pretty significant. Okay, so let's talk a little bit more about what's currently going on. So we have good alignment on the actual numbers that we see in this graph, and they're all up to date. Okay, so as mentioned, the production is 255,500 barrels a day as of January 2025. So if we count for like the previous month, so December 2024, and that production from month over month grew by about 3,000 barrels a day, from 252,000 barrels a day. And that change in production is about 1.28%. The overall number of producing wells right now, and we can see on this chart here, let me delete this so it's easier to see. On this chart, we can see that it's the dotted line, is that black dotted line right here. So right now they have 333 producing wells, and which makes sense on this scale, right? Between 300 and 350. So you can see over time grew in the number of producing wells as function of their kind of incremental growth. But a lot of it could be associated with infill wells integration in their pad strategy. When steam chambers coalesce, you introduce an infill well. And I think as part of our course, we talked a little bit about that in the past, where you can optimize your production, not necessarily drilling well pairs. You can also introduce infill wells and integrate those as well. So production is from 333 wells, so including the infill wells, and they're producing about 255,000 barrels a day. And the average production per well is about 767 barrels a day, which is extremely healthy. So now you're thinking about, wow, it's like 255,000 barrels a day, and you have only 300 something wells. In conventional, for example, you can have over 1,000 wells, and each well will be producing a couple of barrels a day, like especially the legacy wells. But here you have very healthy production. And this is one of the kind of benefits in thermal recovery schemes, is because as you develop the chambers, you have very low decline rate. So the best well produced over 3,000 barrels a day, which is remarkable. I don't know if that's how it's been reported, maybe aggregation of some cluster of wells, but I see them as kind of one producing stream of wells. So if I'm incorrect on that, maybe it's like a couple of wells that produce that, but my understanding it's 3,000, 3,500 barrels a day. That's kind of the best region that produces at Suncor Firebag. So the number of wells above the average that we have is 137 out of the 333, and the number producing below the average is about 196. So we have some wells that are declining over time, but obviously very, very productive asset. And the top 137 wells that produce 67% of the overall production on this asset, and the top 5 wells produce about 6% of the production on the asset. Now, we talked about that oil production is really a function of that steam injection rate, as you can see here. So right now, the steam injection rate is 656,000 barrels a day. So 656,000 barrels per day. So if we look on this scale right here, and I'll use a calculator just to better understand if there was incremental growth in production, and the question could be, well, how is this related to NCG co-injection? Remember, one of the benefits of NCG co-injection is taking away that steam from late life pads or wells and allocating it for future pad development, right? So if I take 656 divided by 6.29, I'm getting about 104. And so if we look right here at this level, it's about 100,000 cubes, and we're right now at 104. So that steam injection grew to that level right here. So everything in this chart makes sense when it comes to the updated numbers. We grew production a little bit, but we're also injecting the steam a little bit more. And obviously, if we think about 656,000 barrels per day of steam injected divided by 255 barrels per day, 1,000 barrels per day of produced oil, we can also calculate the current instantaneous SOR. And we talked about the difference between cumulative and instantaneous SOR. The number right now is about 2.57. So 2.57 kind of on the monthly SORs, right? So when you think about this, if it was 2.7 in 2023, as reported here, so 2.7 before, and right now we're closer to 2.5, 2.6, that means the asset is more efficient when it comes to their utilization, basically, of steam and environmental performance as well, because lower SOR is better for your execution, and because you can do more with steam by definition, but it also lowers your energy intensity, which is great. So they're on the right path, it seems, on both parameters when it comes to their economics and environmental improvement. A couple of more interesting kind of facts that have been recently happening. The SOR, as I mentioned, is about 2.57 on the monthlies. The infill well integration is not that very high, and the reason for it is because the number of steam injectors, like when we talked about the kind of the average steam injection rate is 656,000 barrels per day. That comes from 340 injectors, right? So it's coming from 340 injectors. So here we have 333 producers, but we also have 340 injectors. So you can see this number is, if the ratio is very close to 1. So we don't see, there are some other assets where this number is like much higher. For example, if I was to use kind of relative numerical explanation to maybe other assets could have like maybe 400 barrels, 400 producers and maybe like 250 injectors, right? So then that means that they will have, let's say, producer injector, and then they will have lots of infill wells between those zones. Not in the case of Suncor, which kind of tells us for Firebag, maybe there's even bigger opportunity for infill integration here, right? But there's definitely the question is like, well, what are some of the benefits that have been happening here over time? And for sure, since like December 2023, so for the past 12 years, we've been seeing incremental injection and NCG co-injection, which tells me maybe some of the efficiencies are coming from those type of behaviors. Okay, a couple more comments about recent production, the water cut. So water cut is basically you take the water produced over the liquid, the entire emulsion produced. They're very close to 71, 72% on this asset. And there's very little change month over month in the produced wells. Actually, from November till December, one well was taken offline, and maybe they're drilling more wells that will be coming online in the future, and we could talk about that. But as of now, this is the current status. We have about 333 producers, 340 injectors, and we have 656,000 barrels a day of steam injection rate, which is what we saw here, 255,000 barrels a day of oil produced, SOR 2.57, water cut 71, 72. So a very efficient operation here at Firebag. Okay, so let's focus now a little bit more on our topic, right? So as we defined SAGD, and obviously in our course, right, we're talking here about applied engineering, and kind of understanding of the application of this technology integration. And obviously we have to compare with the baseline. The baseline is that we have and maybe we'll cover it more when we talk about SORs, but we really, in our project, fundamentally we really want to understand what is the benefit of this over time, right? Like how does it benefit? Would I be better off not doing that NCG co-injection? Would I better be off just like utilizing that steam and not worrying about this? And so one of the things where we would value is really understanding that SOR behavior, and that SOR behavior is really realized in this chart right here, right? And so we can see up until 2023, we saw a certain SOR here between 3 and 4, as you can see here, but something happened during that time frame. Something happened, and this is a really important message, right? What happened? We saw NCG co-injection. I'm sure we saw a lot of other optimizations on this asset, a lot of other effort and good work by the team at Suncor. But based on this chart, what we're seeing is that we had a really interesting situation where SOR declined. And right now, as we said, it's about 2.57 or so, right? And it was a little bit higher, but it's clearly declining. So now they're by definition able to do more with their steam than before. So we definitely see a benefit here. And I think this is my ask here from the students, is that when you do your research, when you pull data on your assets, when you compare pads to baseline pads and NCG integration, when you look at the asset holistically, this is the kind of stuff we need to be looking at, because we really need to be able to quantify the benefit of the change, right? It's like in daily life. If you do something, let's say one way, and then you go into like other behaviors, you want to say, am I better off doing that? For example, if you eat fast food once in a while, and now all of a sudden you eat fast food every day, and then there is incremental gain in your weight, and you're not interested in this change, then maybe it doesn't benefit you, and now you need to go back and change the behaviors back, right? Same here goes with NCG co-injection. Maybe this behavior would not have benefited the asset, but clearly in this case it did. The other interesting thing we see here is that there is this fluctuation here in the water to steam ratio. So it really kind of fluctuates here between, I would say, 0.9 to 1.1. But then it could be a function of the different geologies. When you drill pads, maybe you kind of avoid top water, bottom water regions initially. And so by definition, you will have maybe lower ratio, water to steam ratio, but then maybe over time it increases a little bit more. But definitely we can see a big change in SOR behavior. And obviously it has something to do maybe with NCG co-injection, but at the same time, they did decay the NCG co-injection rate here, going from 250 decks a day before in the 2020 timeframe. And as I'm looking at this, let's kind of think about this a little bit more. Kind of what happened in this time frame right here? What happened here that maybe invoked that NCG co-injection? Like what could have happened there? And we have one explanation there that is written, but another one maybe not. Like we know 2020, 2021, we had COVID. So so then there was a lot of NCG co-injection that taking place. But maybe that's not the reason why it happened. Well, the reason here is that starting of government issue curtailments, and kind of quick reminder that 2016 to 2020 was a very difficult year, a couple of years, 4 years of pricing of Western Canadian Select, so the benchmark price of Canadian crude, and there was even a decision on curtailment, and we can see some curtailment, and it's parallel. We can see a big spike in NCG integration. So I don't know if it's like directly linked to that. Maybe there was some effort to kind of pressurize reservoirs and reduce steam, which is kind of what we're seeing here. So maybe that was one of their strategies, is kind of like, let's inject NCG and maybe cut the steam, so we're not necessarily kind of draining that oil in this couple of months. And you can see like on the broader scale, they restored it very quickly and kind of recovered from that. The other things that happened was planned turnaround maintenance. So I mean, as somebody that kind of invests also in the sector, we have a lot of people that kind of intermittently once in a while freaking out about those turnarounds, the maintenance schedules. But those are routines. You need to be able to kind of maintain your facilities. So we can see in this picture, there's significant amount of facilities there. So we need to make sure there's like no corrosion, but there's no failure of parts, and they're being maintained. Just like you change oil on your vehicle once in a while, and if you don't, the vehicle could struggle. Then you need to do maintenance and turnaround, where you do have intermediate shut-ins, just like what we've seen here and here and here, where you're able to kind of do that work. And a couple of other things: Fort McMurray wildfires. We had last couple of years. This graph is not up to date, but there's a little bit more of those events that be taking place. For example, last summer as well. So Fort McMurray wildfires definitely resulting in steam decline. And we didn't see much NCG boost back then. Maybe it was early in their technology integration, but it did impact oil production rate, and then it was restored back. And another turnaround here. And here we can see a lot of basically growth in this asset, a lot of investment, a lot of the growth prior to 2013. Oil prices, I think, between 2011 to 2013, 2014 timeframe, they were closer to $100 a barrel. And that created a lot of optimism in the sector. And that's why you saw a lot of that investment and kind of marginal netbacks going into a reinvestment ratio, if you will, by putting money back and basically building those facilities right here that incrementally created this benefit of steam injection rate and uplift in oil production. So now when we think about holistically, some people, they kind of say, well, companies should just like print money and maybe pay dividends and buy back shares and all that. But clearly, in the past, when those investments were happening, this resulted in today's oil production rates, right, and capabilities to integrate the steam injection, and obviously resulted in 255,000 barrels per day, which is what we know as kind of future cash flow generation. So when you invest here, you basically realize the benefit here. But many investors don't have time for that, don't have patience for that, and it is what it is. But when we go to our technical discussion, NCG co-injection was definitely, as you can see in this chart, integrated here. And congrats to Suncor of achieving 1 billion barrels of cumulative production and improving their operations from last couple of years, especially going from 2.7 SOR to now about 2.5, which is amazing. And as we saw here in this picture. And so I would say one of the lessons and kind of is that look at your unique assets, and we covered some of those already in previous lectures, and kind of try to correlate those behaviors. Like, do you see the same benefit from NCG co-injection on SOR, on steam injection rates, on growth, on kind of that incremental value? And can you quantify that? Is it something that you can see and quantify, just like they did here? They said, okay, well, prior to that, we were here. Now we're here. And there is a big jump. And one could say, well, I don't care. Maybe it's not that important to me. Well, let's kind of quantify this now. If we use this ratio, 2.5, let's say, right? So that really means that for every 250,000 barrels a day, I can produce 100,000 barrels of oil, right? And if my SOR is 3, then for every 300,000 barrels per day of steam, I can produce 100,000 barrels of oil. Well, the delta here is 50,000 barrels of steam. Now, if you utilize more steam, you're more energy intensive. You need more investment. You need more capex. You need more turnarounds and maintenance to sustain those operations, to keep them going. But if your SOR, let's say, is 1, and I know it's not realistic, then you need a fraction of those facilities. You need a fraction of those steam capabilities. You need a fraction of that investment, and that's where the incremental benefits comes. So SOR metric is not only economic metric, it's also environmental metric, it's also efficiency metric. It's a very important matrix in the Canadian oil sands in situ sector, very important. Okay, so I think we covered a lot of the technology integration, the rates, basically understanding what's been taking place, how they got to 1 billion barrels in aggregate production, what SOR they used, how NCG is being integrated, the various rates for NCG, right? So right now they're at 150 decks a day. In the past they were at 50 and even 250 and even 100. But we see that the gas production rate is very close to the gas injection rate. So this is a really big benefit in understanding this chart. Okay, so here they show us the well layout, the different approved project area, which is basically everything. And now the planned horizontal wells that they execute, the pads, and the operational pads, as we can see. And we can see a lot of pads, kind of integrated clusters of pads, and some pads turning that way, some pads turning this way, some going that way. We can see kind of a very unique configuration here. Probably trying to minimize the footprint and the capex while kind of orienting the pads in the development program. And really, what this comes down to is really the function of geology. So let's look at some of that. And you can see here, this is the continuous reservoir isopac map, the thickness depth of the various pays. And obviously, you have a lot of activity in this section. You have a lot of activity here, a lot of activity there, right? So that's how they choose to go. And probably next time they're going to go here, or maybe those regions. And obviously, they told us right here that that's where they're going to be landing, right, in the future, right there. And if we go here, well, that's kind of where it's happening. So you can tell a lot by knowing the geology and knowing kind of the delineation plans and what's been found in those maps. Base continuous reservoir structure map. You can see a lot of the elevation depth was drilled in shallow zones. So in that central kind of, and maybe that's because it's cheaper. Again, this is a very unique asset when it comes to its specific location, because all other assets, they're like 400 meters underground, like the majority of them, 350, 400, 450. This is a little bit shallower here, closer to kind of Fort Mac, right? Continuous reservoir structures, again, we get some insights where the pads are, and you can see where they're going to be drilling the wells. And reservoir zone gas isopoc, so gas, where is the gas located? And you can see they've been kind of avoiding the gassy sections, right? They've been avoiding those. So you can see some pockets here. Maybe they're mitigating by NCG co-injection, maybe they're mitigating by kind of pressure maintenance, but definitely central, very little gas zones, very little of that. And we can see here gas zones shown are inconsequential to Firebag, but included for reference, right? So they basically tell us they're there, but they're not very kind of important inconsequential in the overall integration of the development. So maybe there's a barrier or operational strategy that makes it inconsequential, but I believe them when they say that. And also we see different thicknesses here of those gas regions, right? So for example, you could have like a very little guy here, maybe under 1 meter of overall thickness for that gas. No top or bottom water zones have been identified within Firebag development area. So this is very meaningful, right? This is why this chart here is really important to understand in this context. So if there is no top water, if there is no bottom water, there's no reason for any water to come from other sections. By the way, other SAGD assets could have other formations that bottom water or top water that could distort this ratio between the steam injected and the water produced. And we can see this ratio is about 1, right? It's very clear. And why is that? Is because they tell us no top or bottom water zones. Upper lean and middle lean are present in some parts. And what really means is that we can have some maybe gas pockets, right? And Firebag development area, thief zones potential is unknown at this time, but is actively being investigated. This is probably in line with that inconsequential comment and lots of like little pockets here. But again, we have to stick to the slides. We can't just assume that they say something else. So, as part of this course, we just kind of treat it as a fact for what it is. We're not trying to make too much interpretation of the language that the company is communicating here, but we can see and kind of make some conclusions why things are the way they are, right? What they try to avoid, why they try to integrate NCG, all kind of things like that. So we're gonna skip some integrity disclosures and kind of maybe go into things that more related to our project. Okay. Okay, so let's talk. We talked about in the past about exploitable bitumen in place. So EBIP, exploitable bitumen in place. And the way they define it at Suncor is that each well by the top and the base of the continuous reservoir. So that's the exploitable bitumen. So this is this section really. And continuous reservoir base, lowest portion of the continuous reservoir sandstone with bulk max fraction of oil. So BMFO, cut off 6%, less than 3, and over 50% of mud, breccia in lower portion. So in the past, we talked about how if you have maybe very muddy IHS, inclined hydrolytic stratification, maybe you have very low oil saturation zones, and in regions where you have mud and breccia, those are not included as part of the overall kind of understanding of the producible resource necessarily, right? So they kind of tell us what they classify as bitumen in place, exploitable bitumen in place, or SAGDable bitumen in place, something that could be produced. Upper and lean middle zone and gas zones that are in pressure communication with the continuous reservoir are included with no thickness cutoff. Observation wells and 4D seismic will take precedence over pre-operation core and log-based peaks. And EBIP at Firebag Mackay River is the same as the original bitumen in place. So Basically, they're saying exploitable bitumen is the same as original bitumen, but then I assume the SAGDable bitumen in place will be a little bit less than that, unless SAGDable bitumen in place is the same as exploitable bitumen in place. But we covered this kind of core kind of analysis in the past, and I hopefully kind of it makes a little bit more sense within this context. So let's pick one pad that maybe is let's pick 108. Yeah, so let's pick 108, and let's pick something that's a little bit younger, 111. So what we see here right away, so this is, by the way, summary of pad performance and reservoir properties. So what we see here right away is that recovery to date right here for 111 is 5%, and for 108 is 50%. So we know 108 is a much older pad than 111, and 111 been probably drilled last couple of years, and it's kind of the newer pads that coming online. So now let's remember those numbers, 108, 111, and let's go to our map where we looked at before for bitumen pays, and really understand where they are going. So 108 and 111. So 108 and 111. Oh, okay, right here. So 108. So here we have 103, 109, 101, 105, 118. Okay. All right. It should be here somewhere. I don't see it. Oh, 108 right there. I wrote something on top of it, so I didn't see it. Okay, so 108 right here and 111 right there. So see, it's a little bit more to the left, right? So in new development, they went more west. New development. The recovery factor here as of 2023 was 5%, and this recovery factor was close to 50%. Well, obviously, this is a little bit more central, and everything probably is coalesced in that section as well, right, in this 108 region. And we can kind of see that the new development is going into those areas like 136, 137, 135. So they see a lot of benefit going to the west, and they also go into that section. And I think through here, we can see why is that. So they went here and here, right? And they exploited this first because it had the top thickness, the best thickness there. And that's probably where NCG co-injection is taking place as well. So now that we know where those pads are on the map, let's kind of investigate a little bit further. And again, this is like totally like a spontaneous identification of those pads. And let's kind of talk about them. So hydrocarbon area, they had 1.7 thousand and 1.6 thousand meters square in the area, and continuous reservoir thickness is 36. That's why it was the first pad to go to, and this one is 28, right? So they prioritized better pad development. Porosity in both was 32 and 33, so this is a little bit better here. Average permeability here is a little bit lower, 3.8 Darcy, so 3,800 millidarcy, and 5.4. Amazing horizontal permeability. Vertical and permeabilities for both 2.8, 2.5. Obviously, we can see 108 was supposed to be the pad to go to. Like if you want to collect really nice netbacks on your asset, this is the first pad you drill, and this is exactly what they've done. Oil saturation 74, 76 here. So this is a little bit better now. See, because of the heterogeneity between the pads, because of the geological differences, you can see how the decisions were also made. Recovery up to date, so they produced through that pad 7.6 million cubes. So 7.6 million cubes, think about that. And only 524,000 cubes here, which is that recovery factor. And the ultimate recovery factor, the EUR, which is what you can see here, is 83 and 81. And this is really the main benefit in those SAGD assets, is that not only you recover this thing for many years, you have even more to go. And that production profile is basically kind of like this, right? So it's just like, it's very small decline, very low decline. And that investment that they made between what was it, like 2009 to like 2014. Really incredible, right? Allowed more steam capabilities, more opportunity to produce more resource, and really they're going to be heading towards this 83% recovery factor. Not this year, not next year. This is going to take more time, right? And we can see how they're going kind of more towards the west. So if we draw here, we saw some pads on the east that are being developed here, kind of, and some on the west, and where this was more essential, and that's where 108 was. 108 was here, and 111 was kind of to the side a little bit here. Okay, so co-injection overview. So not surprising at all that based on what we talked about so far, that they basically co-inject NCG mainly in the central area, right? It will be kind of weird now if the story wasn't consistent with our thought process. And again, I'm not a Suncor employee. Nobody pays me for this. I'm teaching right now for this petroleum engineering course, right? Trying to understand this asset. But the logic here is very intact, right? Um, why are we injecting NCG co-injection? Well, because everything here is probably coalesced and very mature, right? So all the pads. So if I draw injector producer here, we have communication, we have all this, and now you have to basically maintain through NCG. You have to maintain, so non-conventional gas co-injection, the steam, the pressure in the chamber, and reallocate that steam efficiently to other pads so they can be developed, right? And so what we see here is that non-condensable gas NCG co-injection had been implemented on the following well pads at Firebag, and they named them. Okay, so we can also see 108 and 111, and guess what 108 was? 108 was the higher recovery factor pad, right? That achieved 50%. It wasn't 111, the little guy. It was 108, and 108 is on this list, which makes sense with the overall theme. Let's see some of the language here. Co-injection overview. So NCG, which is basically methane fuel gas co-injection with steam, has been implemented on 10 mature pads, 101 to 109, since May 2018. NCG and steam co-injection typically commence on a pad when estimated ultimate recovery factor has exceeded 65% through normal SAGD operations. Now, this is very interesting because pad 108 went on NCG co-injection, as you can see. And PED 108 for that time frame was 50% recovery factor, right? So they told us that the cutoff criteria is 65%. And the question is, it hasn't exceeded the 65%, or maybe it did right now, but why they co-injected that? And I think as I'm speculating about what's going on here, I think there's a lot of communication here where we see a lot of other mature pads, right, that have achieved a lot of maturity. For example, 104, 105, so 71, 72%, 70%, 83%. And now, because the pad that at 50% recovery factor is coalesced with the other pads, it kind of comes in with a bundle, and then NCG is being co-injected as well. So this is kind of cool, kind of I guess to think about, maybe make this conclusion, but you guys get the idea. And let me know if in the comments if you disagree with kind of my assessment of what's going on here. But it is what it is. So geological characteristics, SAGD performance optimization approaches, and surface infrastructure are also considered when evaluating timelines for NCG co-injection. So you see, so they basically tell us geological characteristics, SAGD performance optimization approaches, surface infrastructure, maybe the fact that you coalesce with other pads, right? That also kind of being considered for that. The main factor considered to determine, execute, and monitor NCG co-injection rates involve monitor reservoir responses and main key performance indicators, so KPIs, to adjust NCG target rates. Field-wide strategies to cut steam from mature pads and replace with NCG. That's exactly what we talked about. Maintain the desired chamber pressure, so bottom hole pressure maintenance right here on mature pads. NCG retention with reservoir considering the balance between NCG leak-off and volume of the NCG produced back. And sulfur recovery unit, which is the SRU capacity limit, to handle the level of produced gas to the field. So they consider all of those important elements as part of their NCG co-injection. Now, for the students, I ask you to think about how these factor considerations at Firebag Suncor is correlates with your factor considerations in your specific assets when it comes to NCG co-injection. What is your company, the asset you're looking at, is talking about as the consideration factors for their opportunity to invoke NCG co-injection? How are they treating that important threshold? So I think it's important to understand as part of your study in that course and kind of how the strategy is being integrated. So one of those very important considerations. So maybe this is the final slide for today. We're already at 50 minutes, and then we can kind of conclude this. So co-injection impact. As you can see here, in the SPEDS 101, 109, and 116, so 108 was one of the SPEDS that took aggregate production. And guess what happens, guys? The steam rate is declining. Steam rate is declining. Oil rate is also declining, but it may be on a decline curve. But guess what the most beautiful thing about this is that you're able to take that delta of that steam and reallocate it elsewhere, right? It's one of the kind of benefits. I mean, what are you going to do with that steam? And you know how I know this? Is because here they essentially did not cut the steam injection rate in aggregate. The overall steam injection was reallocated on the asset. So if I'm an alien and I'm landing and I'm looking at this asset, it's like, okay, from aggregate perspective, I don't know where the steam went from pad to pad to pad. I just know that in aggregate it operates here, right? But they basically kind of use the optimization strategy to reallocate that steam and accelerate oil production on other pads as well, right? So, and we can see here NCG rate, produced gas rate in this chart. Please compare it to what you're getting. And this is really important because this decline right here, we don't see it on every asset that we talked about in the past. We had a lecture, I think it was lecture 2, 3. We didn't see much of a decline. So maybe there is a time frame when on certain assets when NCG integration is more beneficial. Maybe there are other considerations like what they were telling us here, right? When we talked about the factors that they consider for NCG co-injection. So I think it's really important to consider that. But nevertheless, the SOR did decline, right? And instantaneous SOR continuously declining here, going from about 2.3 or so, and now just getting closer to 2. But the overall trend is going from here and down, right? Downwards, at least from 2018 timeframe. And I think it's important because the overall SOR, the broader one, like from 2004, really, way more meaningful because I think it was like over 3 here, right? And now we're like getting to low 2s. So huge benefit by this technology integration. So let's read what it says here and then conclude our session. There has been no observations on negative impacts on oil rate after NCG co-injection. Now you could say, well, how is that? It's impossible because the oil is declining. But remember, when the steam chamber is mature, there is decline anyway that takes place over a certain period of time. And so through reservoir simulations, they're probably looking at those operations, and then they say, okay, relatively to that estimated decline, we don't see incremental decline utilizing this technology. So that's what basically they're saying. Continuous reduction of steam injection rate. So again, they're basically confirming to us what we've been assuming. Steam reallocated to younger pads. Guys, okay, I'm gonna clap for myself to reward myself because this is clearly what it says right here. Our assumption the entire time was correct. They're taking the steam and they're reallocating and they tell us where it's going. It's going to younger pad to accelerate oil production. And that's how you get to 255,000 barrels a day. That's exactly how you do it. This is the execution path. And good job, Suncor. Amazing. Unable to increase NCG co-injection and further cutting steam in 2022 due to reaching the gas handling capacity limit. Guys, this is very important. And I think this is one of those considerations about growth in production is that you always somehow limited on your ability to handle something, right? You on the kind of the front end, you need to generate steam, but you're limited by your steam capabilities, right? Like you can't just like in initiate steam somehow. It needs to be done through the facilities and what was designed and what was built and what it provides in terms of volumes. Same thing at the back end. You can't handle infinite amount of oceans and water and gas coming at you. You have very specified criteria, and that's why in the gas production rate we saw 150 decks of kind of that capacity that able to handle daily. So, and they tell us here that look, we're unable to increase NCG injection to further cutting steam in 2022 due to reaching the gas handling capacity limit. SOR generally has a decreasing trend, except recently, as explained above, right? Because maybe they reallocated steam and they kind of maintaining that steam to a ratio. Maintained the decreasing trend in reservoir pressure targets by NCG co-injection. Co-injected NCG with steam in the range of 0.15, 0.35 percent mole percent. That basically tell us the fractional kind of molar fractions of what is being co-injected. And during the reporting year, which is 2023, gradual increase in produced gas from reservoir, 40% of injected NCGs produced back. No significant temperature reduction have been observed within existing steam chambers from observation wells, temperature, pressure data. And this basically tells you the efficiency of steam, how good the steam is when it comes to introducing its enthalpy when it's being injected and maintaining that steam to drain that oil by gravity. So I think that is one very useful comment here by Suncor. So huge thank you to Suncor for sharing their D54 in the public domain for educational purposes, information purposes. Hopefully I did justice covering their technology and integration. Amazing job. And for the students, please relate it to your own individual assets, right? So you see how this company is utilizing this technology. You saw a lot of the considerations of how they implemented NCG and why they did what they did. And we covered a lot of those and how it benefited their company, SOR performance, oil rate production, steam reallocation, all of those things. So thank you so much for everyone, and we will meet in person next week. All the best.